Okay, class, good afternoon. So, for now, let's have the stair slab. So, as you can see, you have there the section of the stairs with corresponding reinforcement and thickness of the stair slab. Okay, so you have there the anchorage bars with the spacing as same as with the main bars. Then you have the beam, or sometimes the beams are located here. So you have approximately 1 meter distance for the stair slab. Okay, and then standard tread of the stairs or step is 250 to 300 millimeter. And then you have the standard riser of 175 millimeter. Then the height, this one, it depends on the floor levels or the floor height. You have sometimes that is 3 meters. And then you have the standard steps, which is 16 steps. Normally, if that is a full back stairs with 8 steps per level, so you have at least 16 steps standard. So normally, if that is 3 meters divided by 16, 0.1825, I think. So maybe that's the riser. But for the standard, you have 175 millimeter. And then this length, so it depends on the design of your stairs. So it may varies in several designs. Okay. And then to solve for the depth or effective depth of your stairs, that is the waist. The waist is this one. You have here the corner of stairs to the bottom of the stairs. So that is the waist. Okay. Or that is equivalent to the thickness of the stair slab. And then for the cover, this one, you have, it is measured from the bottom of your stairs up to the middle or the mid center, or that is the center of your reinforcing bars. Okay, therefore your cover, normally standard cover is 20. Okay, so this is 20 millimeter. Okay, so to solve for the cover, you have 20 millimeter plus the diameter of your main bar divided by 2. Okay, so that's the cover. Let's have example. You have here, design a stair slab spanning longitudinally and set into pockets into supporting beams. The effective span is 3 meters, so you have this one, and the rise of stairs is 1.75. So this is your illustration for this problem. And then the width or the tread or the step is 260 millimeters, and then the riser is 175 millimeters. The live load is 4.8 kilopascal, FC prime is 25, Fy is 276. Then modular ratio N is 9, and then use the unit weight of concrete, which is 24, not 23.54. So you will use 24. Okay, so solution of this problem. You are given the tread, which is 260, the riser of 176, and the number of steps is 10. Okay, So in this problem, given is the number of steps 10. Okay, since you have the height of 1.75 divided by 0.175, so therefore is 10 steps. Okay, so to solve for the steps, you have the height of the stairs, that is 1.75 meters. Then you have the riser. Okay, so you have the height, then you have the riser. So therefore, you have 10 steps. And then the waist or the thickness of the stair slab. So let's go back to the minimum thickness for slabs. Okay, so we will use L over 20, or the short span or short side divided by 20, since this is a simply supported stairs or slab. Okay, two supporting beams, and this is simply supported beam, okay, or simply supported slab. So you will use L over 20. Then you have your L that is given, which is 3 meters. So therefore, convert that into millimeters. So therefore, that is 3,000 divided by 20. So you have your thickness equivalent to 150 millimeters. Okay, so round off to multiple of 10 millimeters up. Then normally we will use 12 mm for the main bars, the same as with slab. So we will use the 12 mm main bar, the appropriate bar for slabs, and then 20 mm clear cover. So therefore, to solve for the effective depth, you have the depth is equal to the thickness, this is 150, minus the main bar diameter, that is 12 minus 20. So therefore, it's 150 minus 6 minus 20, so that is 124. Okay, and then let's compute the dead load. So considering the dead load, we only have the weight of the stairs for the dead load. So to solve for the weight of the stairs, you have the weight of the waist plus the step. Okay, so the formula is the gamma of concrete times the thickness times Z. Z, that is the hypotenuse. So to solve for the hypotenuse, this is now your Z. Okay, so to solve for that, that is the square root of 3 squared plus 1.75 squared. So therefore, you have your Z equal to 473. Then plus the step. So the step here, you have this one. Okay, to compute for that, you have the gamma of concrete times the thread. So that is the area of the triangle. Okay, you have the thread and the riser multiplied by 1/2. So area of the triangle is equal to 1/2 times A times B, or base times height. So the base is the thread, and then the height is the riser. Okay, and then the number of steps, and then the 1 meter strip, or that is the normally that is the width. Okay, width. So standard width of the stairs, that is 1 meter. Okay, so to solve for that, you have substitute the values. 24, that is the unit weight of concrete. Then the thickness of the stair slab, that is 150 millimeter. To convert that into meter, so that is 0.15. Then Z, then multiplied by 1 meter, that is the width. Then plus 24, this is the thread, this is the riser, divided by 2, that is the area of the triangle, multiplied by 10, that is the number of steps, multiplied by 1 meter width. So you have the weight dead load is 17.96, and then for the live load you are given 4.8 kilopascal. So kilopascal, that is equivalent to kilonewton per meter squared. So that is for kilopascal. Okay, so you just multiply that by the base and the length. The base is the width, then you have the length of 3 meters. So therefore, you have 4.8 times 1, that is the width, and then the length for L, this one, that is 3 meters. Okay? So therefore, you have 14.4. So total load, you have 17.96 plus 14.4. So therefore, you have 32.36. Okay, so this is now your total load W. Okay, so to solve for the moment, you have here the moment for the simply supported slab. Okay, considering this is the moment 1/8 WL. Okay, or that is, if you have small w, that is WL squared over 8. Okay, that is for the maximum moment for simply supported slabs or stair slabs. So you have your W equal to 32.36, and then L, or the span, is 3. So therefore you have your moment equivalent to 12.135, and then you recompute the D using the resisting moment of concrete to solve for the D. Okay, then you are given FC prime of 25, so therefore compute for FC, that is 0.45 of FC prime. So you have 11.25, and then Fs, that is 0.5 of Fy. So you have now your Fs of 138 megapascal. Then you solve for D. Okay, so solving for D, you have your D equivalent to 77 millimeters, where your D computed from the thickness, based on thickness, that is 124. So therefore, you will use the bigger value for dimensions. Since this is designed, so you will use 124, where your thickness is 150 millimeter. And then you have the steel reinforcement. So bars at bottom where tensile stress is located. So you have the formula for resisting moment for steel. So you solve for the area of steel. Okay, so you have your ms, that is equivalent to the moment. You have here the moment, so you have 12.135. Okay, then you already have your fs and your j. You already have to solve for j, and then your d, you have 124. Okay, so therefore you have your area of steel equivalent to 826. So to solve for the spacing, so you don't have to solve for the number of bars for this problem. Usually for slabs, you have only the spacing, no? Since that is not the same as the beam, that you have limited base or length. For slab, you have the span normally, so that is not the same as the beams. So we'll solve only the spacing, not the number of bars. So for the formula, you have S, or the spacing, is equivalent to the base divided by the number of bars, but the number of bars is equivalent to the area of steel divided by the area of 1 bar diameter. Okay, so you have now transfer to the top. You have the base multiplied by the area of 1 bar diameter divided by the area of steel. Therefore, you have the base or the width of 1 meter multiplied by the area of 1 bar using 12 mm divided by the area of steel. So therefore, you have your spacing of 137. You should round it off to 10 millimeter down. So therefore, you have your spacing equivalent to 130 millimeter. And then from the ACI specs based on slabs, this is for the main bars. So you have the spacing should be greater than 100 but less than 3T. Where your spacing is 130, then your thickness is 150, so your 3T is 450. So therefore 130 is greater than 100 but less than 450. So therefore you can use your spacing of 130 millimeters. And then for the temperature bars, so usually the temperature bars is 10 mm. So using an FY of 276, the area of steel for temperature bars, you have 0.002 times the base times the thickness. So normally the base is the width, then or that is the 1 meter strip. Okay, then you have thickness of 150, so therefore you have the area of steel equivalent to 300 millimeter squared. Then solve for the spacing. You have the formula. Spacing is equal to the base times the area of 1 bar diameter divided by the area of steel. Therefore, you have the base, or that is the 1 meter strip or the width of the stairs, and then the area of 1 bar diameter divided by 300. So therefore, you have 261. Then you should round it off or round it down to 10 millimeters. So you have 260. From the ACI specs for slabs, you have your spacing should not be greater than 5T. Your 5T is equivalent to 750. Your T is 150. So your 5T is 750. So therefore, you can use your computed spacing of 260. So therefore, use 10 mm diameter bar at 260 on center distribution steel or temperature bars. Okay, and then you have the shear and the band stress. Normally for in my experience, I don't need to solve for the shear and the band stress. This is only for beams, but if you have time, you can solve the shear and the band stress. Okay, so normally it's just the same with the beams. Okay, so maybe you can have your computation up to here, the temperature bars. So disregard the computation for the checking of shear and checking of band stress. Normally for shear and band stress, it's safe. Okay, then draw the reinforcing bars or detail. So the same as the slab, you have this distance L over 4, this one, and then this distance is L over 2. Then your main bar is spaced at 130. Then your temperature bar is spaced at 260. For this framing, this is for the thread. Okay, so normally the reinforcing bars is only at the bottom of the stairs. Okay, so that is the computation for stair slab. Thank you.